Today we'll talk about the area between two curves. Our objectives are to find the area between two curves and to find the average value of a function. We have used the definite integral to find the area of the region between a curve and the x-axis over the interval where the curve lies above the x-axis. We can easily extend this technique to find the area between two curves over an interval. Suppose that the graph of both y equals f of x and y equals g of x lie above the x-axis, and both of these functions are continuous on the closed interval ab, and the graph of y equals f of x lies above the graph of y equals g of x throughout the interval from x is equal to a to x is equal to b. That is, f of x is greater than or equal to g of x on the closed interval ab, then the area between those two intervals is equal to the integral from a to b of the top function f of x minus the bottom function g of x dx. To illustrate that, you can look at these two graphs. You notice that the top function is f of x and the bottom function is g of x. That is, the graph of the function f is above the graph of the function g of x on the interval ab. So we have that f of x is greater than or equal to g of x. Then we can use the idea of finding the area under the curve and the x-axis in order to find the area between those two curves. Namely, the bigger area from the x-axis to the graph of the function f can be found using the integral from a to b of the function f of x dx. And then the little area right here, I'm going to call it the area b, where it is the area between the graph of the function g of x, the x-axis, and on the interval ab, can be found using the integral from a to b of the function g of x dx. Notice that how the shaded area, which is I'm going to call a, the shaded area a is equal to the total area under the graph of f of x, which is the integral from a to b of the function f of x dx, minus the area under the graph of g of x, which is the integral from a to b of g of x dx. So that when I use the properties of integral, I can say that the area is equal to, which is the shaded area, the integral from a to b of the function f of x minus g of x and then dx. If you reverse that, you know that the integral can be distributed and you can use the integral of the first function minus the integral of the second function, which will take you to the previous step. So I did that in reverse, and I figured the area between the two curves is basically, I'm using old ideas, recycling old ideas, making a new idea here. So basically, anytime I want the area between two curves, I have to determine the top function, the bottom function, and I have to determine a and b. And then I can apply this formula to find the area between those two curves. Let's look at our first example. We want to find the area of the region bounded by y equals x squared plus 4 and y equals to x and x is equal to 0 and x is equal to 3. It is very clear to me that x is equal to 0 is a, so a from a is equal to 0, and x is equal to 3 is basically b, so b is equal to 3. And I can see here clearly this is x is equal to 0 and this is x is equal to 3. Now I have to determine which function is the top function, which function is the bottom function. To do that, I usually do it on Desmos. So let me show you how I do it on Desmos. So here is Desmos. I basically graph the first function and the second function. F of x is equal to x squared plus 4, which is this function. And then I say g of x is equal to x, which is this function. And then I create the two bounds. This is the first bound. So let me try to change color so you can see it. And then the second bound, x is equal to 3. And then just to highlight this area, I want to find the region between the two curves. So clearly the top function is f of x is equal to x squared plus 4, and the bottom function is g of x is equal to x. So you can determine the top function and the bottom function using desmos.com. So after we determined the top function and the bottom function, you can find the area between the two curves. Notice how I'm saying curves. In math, we call lines curves. We want to find the area between those two curves, and the area between the curves says it is the integral from a to b of the top function f of x minus the bottom function g of x dx. Now understand this as the top function and this is as the bottom function. It doesn't matter which one is named f of x and which one is named g of x. Sometimes you will have the first function as g of x and the second function will be f of x, but still g of x will be the top function, so you're going to write the top function here. You have to understand that very well. So if we do that, we will have the area is equal to the integral from 0 to 3 of the top function, which is x squared plus 4 minus the bottom function, which is x dx. So we integrate, so this is x cubed over 3 plus 4x minus x squared over 2 from 0 to 3. So this is equal to 3 cubed over 3 plus 4 times 3 minus 3 squared over 2 minus the other half, which is 0 over 3 cubed plus 4 times 0 minus 0 squared over 2, which is eventually going to terminate, is going to be 0, and we need to calculate this value. So I'm going to calculate that value right here. It will be equal to, the area will be equal to 27 over 3, 9, plus 12, minus 9 over 2, which is basically 21 minus 9 over 2, which is 42 over 2 minus 9 over 2. That is equal to 33 over 2, or in other words, it is 16 and a half. So this area is going to be 16 and a half unit squares or square units. Let's look at another example. We want to find the area enclosed by y equals x squared and y equals 2x plus 3. Again, you can find the top curve and the bottom curve using Desmos. As you can see here, I found the top curve to be the function y equals 2x plus 3, and the bottom curve was y equals x squared. But there is another issue. I will need boundaries, so I will need an interval to figure out the area on that interval. I don't have that explicitly in the question, but from the graph I can see that this region ends at this point where x is equal to -1, and you could figure that out on Desmos by clicking on that point. And it goes all the way to this point right here where x is equal to 3. So basically a is equal to -1 and b is equal to 3. You can find that algebraically. Notice how when these two graphs intersect, that means they are equal to one another. So to find the intersection points, we put the first graph is equal to the second graph and solve. So basically we will have x squared is equal to 2x plus 3, and then we will have that as x squared minus 2x minus 3 equals to 0, which will give us x plus 1 times x minus 3 equal to 0. And then we solve, so we will get either x is equal to -1 or x is equal to 3. And we get the same points here. So either way you do it, it's correct. Now, let's go back to finding the area. We know that the area between the curves is the integral from -1 to 3 of the top function, which is in this case 2x plus 3, minus the bottom function, which is x squared dx. And then we integrate, so we will have 2x squared over 2 plus 3x minus x cubed over 3 from -1 to 3. And that will be equal to x squared. The 2 is going to cancel with 2, so we will have 9, 3 squared, plus 3 times 3, which is 9, minus 27 divided by 3 is 9, minus negative 1 times negative 1 is 1, minus 3. 3 times negative 1 is negative 3, and then plus negative 1 cubed is negative 1. Negative times negative is positive, so negative 1 over 3. So this will be equal to 9 minus 1 minus 3 is negative 2, plus 1/3 is negative 5 over 3, which is equal to, the area is equal to 9 plus 5 over 3. That is 27 plus 5 over 3, 32 over 3, which is equal to 10 2/3 square units. Let's look at another example. Example number 3, find the area of the region enclosed by the graphs f of x is equal to x cubed minus x squared and g of x is equal to 2x. When I plot this on Desmos, I notice that I have two regions. This is the small region, the green region. I'm going to call it A, and this is the bigger region, which is the purple one. So I will need to perform two integrals and then add them together in order to figure out the entire area, meaning I will find the area for this small portion and then find the area for that portion and then add them together. Notice that for the first part, I have the boundaries and I have the upper curve, or the top curve is f of x and the bottom curve is g of x. For the other region, the region B, the top curve is 2x, which is g of x, and the bottom curve is f of x, which is x cubed minus x squared. So for the region A, to find the region A, it is the integral from when x is equal to negative 1 to x is equal to 0. So from negative 1 to 0 of the top curve, which is f of x, which is x cubed minus x squared, minus the bottom curve, which is in this case the line 2x. Again, all of this can be done on Desmos. To find the boundaries, you just click on the intersection points, and then you can recognize the top function and the bottom function, or the top curve and the bottom curve, using Desmos directly. So this is the first one, dx, and then I am going to figure out the answer here. And the region B is basically the integral from when x is equal to 0 to x is equal to 2. So from 0 to 2 of the top function, which is in this case 2x, minus the bottom function. Notice how I'm going to put parentheses, because the bottom function in this case is not one term, it is more than one term. I know that this negative sign is going to affect what's inside, so I'm going to put parentheses there. To be safe, always put parentheses. X cubed minus x squared dx. So I'm going to find the first area and then the second area and then add them eventually together. So to do that, this is equal to x to the 4th divided by 4 minus x cubed divided by 3 minus 2x squared divided by 2. These will cancel from negative 1 to 0. So this is equal to, if you plug 0, everything is going to be 0. So the first part will cancel, minus, and then you plug negative 1. Negative 1 to the 4th power is positive 1. So it is 1 over 4 minus negative 1 to the 3rd power is negative 1 times negative is positive, so positive 1/3, minus negative 1 to the 2nd power is positive 1, so it is going to be positive 1. So this area is going to be negative 1/4 plus 1/3 minus 1 is equal to negative 5 over 12, which is negative times negative is positive, 5 over 12. It makes sense to be positive value because it's an area. Then I will find the second area, which is the bigger area. I'm going to distribute the negative inside first and then eventually integrate. So this is the integral from 0 to 2 of 2x minus x cubed plus x squared dx, which is going to be b is equal to 2x squared over 2. These will cancel. Minus x to the fourth divided by 4 plus x to the third divided by 3 from 0 to 2. So this is basically 2 squared is 4 minus 2 to the fourth power is 16 over 4 plus 2 to the third power is 8 over 3 minus 0, because this will be 0 minus 0 plus 0, which is going to be 0. So the final answer will be 4 minus 4. Those will cancel together, and you'll have 8 over 3. So the region A plus B is going to give you the total area, which is 5 over 12 plus 8 over 3, which is 5 plus 32 over 12, which is equal to 37 over 12, or 3 and 1 over 12 square units. The second objective is to find the average value of a function. Here is the definition. The average value of a continuous function y equals f of x over the interval ab is given by 1 over b minus a, the integral from a to b of the function f of x dx. Let's look at some application of that. So here is the example. Suppose that the cost in dollars for x table lamps is given by c of x is equal to 400 plus x plus 0.3x squared. First, we want to find the average value of c of x for 10 to 20 lamps. Second, we want to find the average cost per unit if 40 lamps are produced. So to find the first part, which is the average value of c of x, we know that the average value is equal to 1 over a minus b, the integral from a to b of the cost function in this case. So that will be 1 over 20 minus 10. A is equal to 10 and b is equal to 20. The integral from 10 to 20 of the cost function, which is 400 plus x plus 0.3x squared dx. And then we're going to integrate that function and find the answer. If you integrate, then you will get 1 over 10 times 400x plus x squared divided by 2 plus 0.x to the third from 10 to 20. And then you find the integration, multiply with 1 over 10, your answer, and you will get 485. So basically, we say the average value of the cost is $485. The second part is the average cost per unit if 40 units are produced. Is basically the average cost function evaluated when x is equal to 40. So to find the average cost function, we're going to divide the function by x. We're going to say the cost function divided by x will give you the average cost function. So we divide every term in the function by x. You will get 400 divided by x plus 1 plus 0.3x. Then you're going to evaluate this function when x is equal to 40. So you plug 40 instead of x, and the final answer is going to be $23 per unit or per lamp produced. Thank you so much for watching, and I will see you in a different video.